Hello, everybody. Welcome to my talk about my project called Android Project Creator, which is not the most creative way, but I think it conveys the message quite clearly. I have a small table of contents for the talk of today. First, a bit about myself. Who am I? Then I'll be talking more about the analysis of Android applications in short, the layout of a Android package, also known as an APK, and then how to analyze an APK. Because you're starting with a file and you basically want to end up with the code you can analyze and work with. You want to understand what's happening within the application. Then about the decompilation itself, as that is also a process on its own. Then the advantages of Android Project Creator, which is the main part of the talk. And in the end, there's time for questions. If there are more questions than can be asked, I'll be in the chat after the talk as well. So we can address all the questions that you might have about the tool or the talk itself. So who am I? My name is Max Kersten. I go by the nickname of Libra. On Twitter, I use the Libra analysis handle. For those interested, I'll be sharing the slides of this presentation later via Twitter. I graduated my bachelor in cybersecurity cum laude in January 2019 in the Netherlands. During my studies, I worked as an Android malware analyst for Threat Fabric. I tend to write blogs about reverse engineering in my spare time, mainly about my binary analysis course, which features a variety of articles about reversing and how to approach that in a step-by-step manner. I write custom tools that I open source on my GitHub. One of these is Android Project Creator, obviously. I gave a workshop at BotConf 2019 about the static Android malware analysis, where also I featured this tool as part of it. And currently I work at ABN AMRO at the GCIC on the Global Cyber Intelligence Center, where we focus on the outside threats that we see for the bank, and we provide timely and actionable intelligence to internal departments. We focus on research. We also want to give something back to the community. And part of that giving back is a talk such as this to help other people with their research. So moving on to the layout of a Android package, one of the important things is the Android manifest, which is a XML file. With a tool like APK tool, you can decode this file from the APK itself. And there you can see the permissions that the application requires. So these applications can be used to read internal file storage, connect to the internet, use the accessibility service. Whatever the application needs that is defined within the operating system is in here. Then you have the classes.dex file, which basically contains the compiled classes. Now there's a limit as to how many classes can be in a single classes.dex file per the Android operating system. So one Android package can have multiple classes.dex files in them, where you have the classes n.dex as a naming scheme, where n is a number, ranging from 1 upwards. I haven't seen more than 2, but theoretically that should be possible. Then you have the resources file, .arsc, where you can find the embedded resources, which is the views within the applications, the menus that you see. Then you have the meta-in folder related to certificate information signed by the developer of the application. You can often use this in Yara rules, for example, if you want to match on a specific developer to see what was brought out by a certain developer, if the same certificate is used in a campaign, for example. And you have the library folder in case there are native files that are used, because you can also write part of the application in C if you wish to do that, and you can connect that. So the libraries are present in multiple architectures, 32 bits and 64 bits, and multiple flavors of ARM as well. These are always the same in terms of functionality. So if you're reversing and you tend to prefer 32 bits over ARM, for example, then you can pick your flavor and work with that. Then you have the assets folder, mostly contains arbitrary files that are used within the application. where you can also store an encrypted classes.dex file, which is later loaded. This is a common loading technique in Android malware. And you have the resources folder, which contains the resources that are used in the application. So you have backgrounds of different sizes for mobile phones of different sizes, because downscaling would still require memory and more processing power than using several images and just picking whichever fits best, for example. So that leads me to the analysis of an APK. A lot of questions I generally get are, where do I start? Do I need an additional phone? Do I need to use an emulator? Do I need to work with Linux because that might work better? Well, where do you start? You can start in a variety of ways. One of the is statically, which is how you can use Android Project Creator, because you convert the APK into an Android Studio project. But you can also run it on an emulator if you want to. Depends on the goal you have when analyzing. So do you need an additional phone? If you're just here to pen test normal applications, you might want to use a different phone, but you could use your own. However, if you're into analyzing malware, then I suggest you do not use your own phone. And you either use an emulator or something different. As for the fact if you should use Linux, I would suggest you use whatever you are most comfortable with, which can be Windows, a Linux distribution, any flavor of macOS that you enjoy using, because essentially it's about your way of working and how you can use your knowledge the best. Is obviously without restrictions that certain operating systems impose on you if you don't like those. So to decompile an APK, you need multiple steps. You need to decode the APK twice if you want to get all information, because if you use APK tool for this, then you can either get one part or the other part. That's a bit too more in depth to go into now, but basically you need to run it twice to get all the information. And then out of the decoded information, you get the classes.dex file. And you need to convert this into a Java archive. Once you've done this, then you can use any normal Java decompiler to get your Java code. And then you can merge the Java code, the resources, the SMALI, which is the, quote unquote, Java assembly, to put it roughly. You can merge all that together in a folder structure you enjoy working with or you find suitable, and then you can start the analysis. Obviously, you can also use different tools to open an APK, instantly see the Java code and some more information. But if you want to get everything that you can from the APK, then this is the way you can work. Well, like I said, you can use APK tool to obtain the manifest, the resources, the SMALI code as well. And then you have dex2jar to convert the classes.dex into a Java archive. And then you can use any existing Java decompiler. So one of the decompilers could be JDGUI, Fernflower. You can use JetX, you can use CFR or ProCyan, I presume, because as far as I remember, it's made by someone who's French. So these are the tools you can use there. Nearly all of these tools have a client R command line interface only. Some of them have a GUI as well, as especially JDGUI's name implies, but JetX also has a GUI. So since all of them have a command line interface, you can also automate the process entirely. And this also doesn't require you to remember all the commands that you used to use for each of the tools, because they're different, obviously. And automating is, always faster than doing manual work. You can also have a different approach. You can use, for example, Radara 2 to directly disassemble into SMALI code. And if you have plugins for that, such as R2Deck, you can also decompile it. You can use Ghidra as well to analyze an APK, or you can use Jeb by PNF Software. The reason why I'm not going into further into Jeb is because this is the only paid tool that is in this list. Furthermore, all of the tools are available for free, and most of them have their source code published. So you can either build your own version or use that. So that brings us, after the basics, it brings us to Android Project Creator. So what does it do? Well, basically, Android Project Creator combines these tools into one program with one interface. In addition to that, it uses all the resources that it gathers. Like I said before, the Smiley code, the resources, the images that you get out of it, the Java code, and it combines this into an Android Studio project. So it copies it into the format that Android Studio project would look like. For those who are following along either now or later on, you can get it from GitHub, which has a link with more explanations to my website as well. And for those who are on Remnux, you can also use it from there. Do expect some friction because you're using decompiled code in an IDE. So naturally, there are going to be errors, not only with the code, but especially with the resources. If you're decompiling a really small application, the chances are that your code is actually fine, but the resources, I've never encountered proper resources due to the way they are decoded. So expect some friction there, and also ensure that you use Android Studio properly, in the sense that you configured it properly. I'll go into one of the pitfalls later on in more detail, and I'll note others as well. But also note that decompilation does not always produce code and does not always produce correct code. So the people who are or have analyzed more applications by reverse engineering, be it on Windows, Mac, or Linux, or Android, or iOS for that matter, are aware of this. But especially for those new to the trade, you're not always ending up with code that is correct, and sometimes you're not ending up with code at all. This is also the reason that Android Project Creator has all of the mentioned decompilers included in the project. So you can, by specifying the decompiler as a command line interface argument, you can just switch the decompiler if you think the code is not correct or if you're not getting code at all. And lastly, that goes without saying, for any of the reverse engineering tasks, be creative, both in finding solutions, but also in finding workarounds when you encounter errors in general. So why use Android Project Creator? There are multiple tools out there. What is the added benefit? Well, it runs on Java, so it runs cross-platform on Windows, Linux, and macOS. I last tested macOS when I still had access to a MacBook. This was a few years ago. The basics are not really have not really changed at all, but it's not fully tested. So if you're using macOS and you encounter an error, then it could be due to a lack of testing. If you find an error in any way possible in the tool, then feel free to open an issue on GitHub. I'll get back to you and we'll figure out a way how to solve that. We've solved multiple issues in the past like this. Another really unique advantage is the visualized views that you have in Android Studio. So when you open the view, it gives you like a GUI version. For those who have programmed with Android Studio will know what I'm talking about. So instead of viewing the XML, you're viewing a visual representation, similar to viewing HTML source code or viewing it in the browser. So this gives you a quick overview of what you're looking at and how you can use this. You can also fix decompiler mistakes and remove garbage code. Well, decompiler mistakes happen from time to time, and when you spot them, you can fix them. Garbage code is often inserted as a form of obfuscation. And if you're looking at the code right now, that's not an issue. But if you are looking at the same code in 3 months, then you have to see again which of the code is garbage and which is not. So removing it on the first go makes it really easy if you get back a few months later, because maybe you go from 1,000 lines of code back to 30, and looking at 30 lines of code that actually makes sense is a lot easier than going through the same garbage code again. That saves you time. Not all tools allow you to edit the code in general, or refactor for that matter. So this is one of the advantages you're having as well. And one of the other unique advantages is the interactive usage of the manifest. Like I said, it declares which permissions are used, but it also declares, for example, the main function or main class in which contains the onCreate function, which is the starting point when you first open the application. So you can use Control-click when you're pressing on the class name in the manifest, and then Android Studio automatically jumps to this class, which is not present in any other tool I've used so far. You have all the information in one place. You have the Java code, the Smiley code, your resources, your libraries, everything. And if you're using or viewing one of the enumerations that are within Android's code base, assuming you have the correct data set installed within Android Studio, the build tool, so to say, then you can actually view this documented. So you can see what the original Android development team wrote for this value of this enumeration, and you can work with that rather than going onto the website and finding out what it is. So you're also always working in an up-to-date environment, because Android Studio is the main way to develop Android applications. Updates are being pushed for every new version. There's an emulator embedded. You can do anything to create apps with it, which means it's always up to date, and you're never lacking in terms of versions or working with outdated software. Android Project Creator can also be used in an automated sense. You can run it as many times as you want to convert APKs into Android Studio projects in the backend somewhere. And there's also support for some commercial tooling. Like I mentioned JEB before. JEB is supported via a script if you can run JEB headless. Requires you to have the JEB Pro license in that case. So not only the Android version, but the bigger license. But it's also included if you're working with that and find this way of working more convenient. So the flowchart I showed before is basically shortened to one action, which is run Android Project Creator, and then you can open the project in Android Studio, and you can start working with that one. So how to further utilize this? Well, there are basically a few options for the command line interface. You can install. This means that in the folder where the jar is located, a new folder will be made named library. And in this library, all dependencies will be installed, meaning they will be cloned from GitHub, which is either the official GitHub of the tool or it's a mirror on my own GitHub, because not all tools are available anymore. Pardon me. The update version requires you to have first installed it, obviously, but it doesn't git pull from all the repositories again and then rebuilds all the dependencies. The decompile will mostly be used because this is where you transform your APK into an Android Studio project. And then we have the compact installation, which basically fills your library folder with a pre-compiled version of all the dependencies that are hosted on my GitHub. So if you trust my GitHub enough to do this, this will shorten your installation time depending on your internet download speed, of course. But from maybe a few minutes into a few seconds. But that is up to the user. And one of the future updates that I have is the compact update, which allows you to refill the library with the pre-configured and pre-compiled toolset, because currently you need to manually remove it and then install it again. We're currently at version 1.4 stable for those watching this in the future. So there are a few prerequisites for Android Studio, for Android Project Creator. You need to have the Java 8 runtime and the Java 8 development kit. Not really because of Android Project Creator itself. It should be able to run on any Java version, but multiple of the dependencies that are being used do not function beyond Java 8. So keep this in mind. And you also need to have any recent version of Maven installed during the build process of one tool. So if you encounter any errors during the installation, note that Android Project Creator is using the installation build process as a wrapper around your system shell. So that means it starts either a shell or cmd.exe, runs the command that it needs to run in order to start the build process. But if there's any error, the project will be, well, failing to build, and then the next one will be found. Now, this can be the case for some decompilers. In that case, you can either write a note or have a mental note to not use that specific decompiler because it's not present. You can also try to fix that. So keep in mind, if you look to fix this, scroll back into the standard output when you executed Android Project Creator, because it's not at the end, it's somewhere in the middle probably where your error is, and then you should be able to work it out from there. If you need any help, then just post a message or send me a direct message on Twitter. I try to keep up with the messages, so give me some time to respond, but you should get a response. So once you've fully installed the tool, well, there's a lot more standard output that goes before this, but it will verify your tool set that you're currently having. And if this verification is successful, you'll just get the message that it's successful. And if not, it will state to you which tool is missing. And if a tool is missing, it is really likely that the build failed, or it was magically somehow not present for another reason. So you will get a notice at the end as well that states, well, maybe CFR is missing for some reason, and then you can scroll back up into the logs and know where to look for at the start of the compilation of CFR. So this is the help menu as well, actually, which is posted at last with the indentation for the install, compact install, update, etc. And that brings us to the second part for the decompilation itself. So you need three things for the decompilation. You need the decompiler name, which is listed on this slide as one of the tools. They are all case insensitive, in case you were wondering about that. But you can use CFR, Fernflower, JEDEX, JDCMD, which is the decompiler part of JD GUI. You can use Procyon, and if you have a JEB3 license, like I said, you can use that as well. For the JEB one, you need to have slightly different commands to explain in the help menu, but I'll not go into that in this talk, as I'm focusing on the majority of the tools here due to time constraints. So you need the decompiler name, and you also need the location of the APK Android Project Creator needs to read and use. And you also need the output location for the Android Studio project. Now, there are a few notes to make on this. Both the path to the APK and the output location can either be in full, or they can be relative from your current terminal or command prompt's working directory. And the output folder does not have to exist before running the decompilation. However, if more folders within that folder already exist, you will get an error message. So at the bottom, you'll see the Java -jar command to run the Android Project Creator jar, stating the decompile flag with Fernflower for this example. And then in my home folder documents, I have a APK named malware. So it's reading from a full path, but then I want to make the Android Studio project in the location that my current shell is, which in this case makes a new folder named malware-fern. So this is one of the tips I'll also give. Append your Studio project with the decompiler name, because if you encounter errors later on, then you know for sure which decompiler you used. But it's also easier to just compare them afterwards, or maybe run it with 3 decompilers from the start and then just see where you end up in the end. So the decompilation will, well, obviously show you all the output of the decompiler itself. It will then read the Android Studio project into a temporary location. In this case, I was working in my videos folder. And then in the library folder, which is from Android Project Creator, there's a temp folder. And in that temp folder, there's a new folder for each instance that you run, where all of the temporary folders are managed. Then it tries to find everything that it needs for the manifest, the resources, native libraries, Smali, everything that is needed. And then the temp folder is copied into the location that you last specified as the last argument. And then the temp folder is cleaned. So this gives you the Android Studio project, which you can then open. And then there are 3 main notes I want to make. Pardon me. One is missing build tools. This will be an error that you'll get, or a notification from Android Studio. Do install these. And just pick any version, preferably multiple, because this gives you all the files that Android Studio will need, but also will give you the, like I mentioned before, the documented code when you're looking into enumerations or classes. Also expect errors. I mentioned this before, but I learned that quite some people do not expect these errors, so I'll reiterate that again. And refactoring is actually one of the struggles I initially had. When you're refactoring code, and I'm using the NetBeans keybinds in Android Studio, so your keybind is very likely to differ. But if you press Ctrl-RR in that case, then this menu will pop up that I have put in the screenshot. Originally, the search for text occurrences and search in comments and strings are enabled. This means that if you are refactoring code, then you're also messing with strings and comments that you maybe have made before. Do make sure to uncheck these, because otherwise you're messing with more than the variable, class name, package name, function name that you have selected to change. So that's actually one of the biggest tips I have for that part. Because this took me a while to figure out why this was happening, as this menu does not pop up when you use the single hotkey. So if you press Ctrl-R, you can refactor, and if you do it twice, Ctrl-RR, then you'll get this this pop-up. So those are the tips when analyzing it with Android Studio as well, which leaves me to ask if there are any questions from the audience. But I'll assume we first go back to the studio for that.